elementary school, I did the same thing. I'm hoping there's at least one kid in there who quite possibly could obsess over it for the next, 15 years until he figures out how to do it. But I present this to you and then film it. I just really want to see this done. Not necessarily this room, but I'd like to see a room being done upside down.
That's not one of the scenarios for an automatic A, right?
It is not.
Okay.
No.
Sorry, you're coming in here with everything.
Let's get work. for that.
What you would get is a whole bunch of extra credit in here, and that's,
That's the important stuff.
it actually, I thought about it, and about the number of students that I bump up, that are just shy of that next grade, these are the points that really make a difference for those borderline students.
You could do super glue if everything's flat, because super glue only breaks if
Yeah,
it's shearing or if it's.
but I think if you did, the flat part are obviously the cross supports, and I don't think that they can withstand the weight.
Yeah, it's like you have to reinforce the whole ceiling up here, at least on these tiles.
I always thought about tying it into the pipes up there. There's gotta be pipes up there of some sort, but
Yeah,
I don't know.
Oh, I say don't.
That water line that's
Oh, yeah.
quarter inch the whole way is probably not gonna hold up the whole table.
Yeah, I don't wanna walk in and find that one of the pipes is burst and there's water everywhere.
Get a brass water line, whoop.
All right, let's make it more complicated. And then we'll get into the alternate technique. Let's do this one. Now we'll keep it at 12 volts. Let's see, what's it here? 1 ohm, 2 ohms, 3 ohms, 4 ohms, 5 ohms, 6 ohms, 7 ohms. And what is the current flowing across each resistor? Stop, I'm gonna change this, and I'm sorry, I started writing it down. I'm gonna connect it more to a lab that I do some years ago, but not every year. I don't know if I had one there or not, but I guess not for this example, then. We'll make that 1, 2, 3, 4, 5, and 6. What's the current flowing through each resistor? Oh, okay. 12 volts. There's another resistor in there, but I'll leave it off for now. I'm gonna pause the video because don't want people to get too excited over this.
Would the 6 ohm, 5 ohm, 4 ohm, and 1 ohm all be in parallel?
No.
Okay.
You went one too far.
So would you group
5, 4, 6, 5.3.
6, 5, and 4.
6, 5, and 4, that's parallel. Because that's one giant junction right there. but over on this side, I've got that junction. The only three that are between those two junctions are these three. Everything else, you've got more than one thing there.
And then the
3 and 2 are not.
Oh.
Yeah.
3 and 2 are,
Those are in parallel, those three are in parallel.
Okay.
So then you can take it as two sections.
So, somebody get 6, 5, and 4 in parallel,
Five, two.
or 2 and 3 in parallel?
Yeah, 6 over 5.
Okay. One point two.
That's 60 over 37 for the top three.
And then do fractions, translate.
1.621, 16.
Okay. Now what?
Now we go to each junction
I've got
and
a junction there and a junction there.
so, at that point, there's no split. It could go down and just hit that one, right?
Oh, the current, you said it can split or cannot, does not split?
It splits there.
Okay, so a current flowing in here, and then it splits,
So I have 2 options.
okay?
So, okay, before I do this, let me ask a question. What I did was, I said, what if it didn't go down 1 and it went over, oh, not 1.
You just waved me off.
I'm scared, listen.
so
Hey,
the,
we all make plenty of mistakes in here.
the 1.62 and the 1.2 are in series.
Yes, so you can take that route, there's more than one way of doing it, but because they're in series, because the current does split there, and any current flowing across there, it has to flow across there. Alright, so I've now broken it down into this, I got my 1 ohm there, and then 2.82162.
And now those two are in parallel.
Yeah, okay. So what's the equivalence? I did it differently, so I don't have it written down.
Zero point 378. Yeah, 0.3.
Did you? 0 point, that seems awfully low.
You have 1 over 1.
Right, plus 1 over 2.82162,
Yep, and that's gonna equal 1.3544.
and then take the reciprocal of that.
And I got the 0.738.
Oh, I misheard then, sorry.
Oh, okay.
0.73833.
33.
Okay? I missed the 7, that's why I knew 0.3 was way too low. Alright, So therefore, what can we find out now?
The current,
Out
the
of
total current,
what current?
would it be like of the overall one?
Okay, or the current coming out of the power supply, or into the power supply, depends on how you roll. So from this, what is the current?
16.2529 amps.
Alright. So, just recognize we haven't actually answered any of the question about what's the current flowing across each of the resistors, but it is important to know that. Now what?
I guess we plug it back in for each resistor,
That current?
the yeah.
Yeah, except that current breaks up as soon as it gets to the first junction. None of the resistors have that much current flowing through them.
Well, if we look at the, drawing you have on Brown, or the last one you have drawn there.
This one?
Yeah, that. We know that the voltage is the same across each resistor,
Right?
so we just do, I guess, I equals V over R,
Okay, so I equals delta V over R.
and then plug in our 12 volts and then each of our resistors.
Because if I gain 12 volts here, I have to lose 12 volts if I go this path, or I lose 12 volts going across this path. And so I got 12 volt drop here, and so 12 divided by 1, I'll do that one in my head. And then 12 divided by 2.82162. Or I have 16.2529 coming into the junction, and 12 go down this way.
So 4.2529.
It better be. And then we can double check by doing 12 divided by that to see if we get the same thing.
Seems right.
Yeah, I'm pretty sure I got it. All right, so I now know the current that is flowing along this path.
Can you divide that number by the resistance of the two running on that path?
We divide, sorry, the 4 point, that's amperes.
Do we take, sorry if I'm interrupting.
No.
Do we take the 4.2529 and use that for 6, 5, and 4?
No, because that current that's the current that does not go down that path, but that current will split into 3 different amounts.
Okay. So then do we divide it by 3 and then figure it out like it's normal parallel, or?
No, because it's gonna follow the path of least resistance, so you can't just divide by 3 like it's a ratio. You just keep working your way backwards. Use your 60 over 37 ohm and 1.2 ohm.
And do what with it?
Well, I don't really know, because they're in series, so I don't. Is there?
Right. When you start working your way backwards or something that's more complex like this, you're basically gonna be flipping back and forth between, I found the current, all right, now I can find some potential drop across something. And then once I have that, I can find current again, and then I find potential drop and current and potential drop. So you're gonna flip back and forth between the two.
Yeah.
So once we have this current that's going along this path right here, find the potential drop across each of these resistors. Because the potential drop across this is the potential drop across these two.
Right.
Potential drop across that is the one across these 3. And if you said that, I apologize,
No, that's what I'm thinking, I'm kinda confused at that spot right there.
So how do you find potential drop across the resistor?
V equals IR.
Yeah.
Yeah, all right, so I've got 4.529 amperes across this 1.621620 resistor, so what is delta V here?
Where did you get that 4.2529 again? For the top one?
Because we figured out 16.2529 amps coming out of the power supply, and it splits. Because I know there's a 12 volt drop across here, that there's 12 amps going across it. Because, well, I is delta V over R, it's a 12 volt drop with resistance of 1 ohm.
Yeah.
Alright, so we have that, and so, well, if I have 16 point something coming in and 12 going this way, I gotta have the remainder going that way.
5.429 volts.
Wait, up here?
Yeah,
Wait, you had what again?
I had 5.429.
5.429 volt drop there, and like minus. Going that way, and so, what's the drop across here?
What was the number now?
This is 5.429.
Across.
Across this mess right here. Because this is the equivalent resistance of those three was the 1.62162 ohms. And so the potential drop would be the current times the resistance, tells you how much we lost.
And is it that same current against the second resistance there too?
I guess this one?
Yeah,
Yes.
okay, so that's 5.103.
Something's wrong.
Yeah.
Did you parenthesize, did you put in the 60/37 and not?
Oh, I accidentally typed 47, that'll do it.
Okay.
All right, how did I know something was wrong?
Because it didn't equal 12.
Right, okay. So going that way, I lose that one.
Well, I guess we can just.
Yeah,
Yeah.
recognize one small mistake there. He typed in a 47 instead of a 37, and not all the rest of his answers are gonna be wrong. So, and again, this is aimed mainly at 110 students. Please show your work.
6.897.
6.897?
Yep.
All right. Did you do it with 12 minus the 5.103, or did you do it the other way? If you did it the other way, what do you get?
I assume the same.
You'd hope so.
Yeah. I'm just seeing if it's still the same.
Yeah.
I'm getting my numbers right.
It's not a typing you're doing over there.
Trying to figure, I can't
We're
remember.
good to go.
You got the same thing?
Yeah.
Okay.
I put the wrong thing in, and I deleted it, and then I put the wrong
Okay.
thing in.
Another day at the office. All right, so we now know what the voltage drop is between this spot and this spot, so going from here to here, across any of these paths, we're gonna lose 6.897 volts, and then going from here to here, either path, the 3 or the 2, we lose 5.103 volts. And then this way we lose 12 volts. All right, so now, what are the currents?
Then we just take that number and divide it by each resistor, correct?
Yep, that divided by 2, that divided by 3, this divided by 6, then 5 and 4.
Just making sure.
All right, let's see what we get. I'm going to, I guess we don't need this. Yeah. What do people have?
I've got the bottom two,
Alright,
three
so
and two.
What do you have going across the two?
2 is 2.552. And across the 3 is 1.701 amps.
Yep.
It's kind of getting messed up because I take that whole number, the 6.2, or the 6.2 is 6.8, 6.897 and dividing it by 4. And then I'm doing the same with the 5 and doing the same with 6. And I'm getting like
1.494.
yeah, and then if you add them all up, they're not 6.
Alright, so what did you have for each of these?
I got, for the 6, I got 1